Hello and welcome to our specialized series on industrial artificial intelligence. We are bridging the gap between advanced data science and the practical, high-stakes world of engineering and production. Today, we will talk about decision trees. Every morning, you make a simple decision. You look outside and ask yourself, do I need a coat? You check the sky, you notice the temperature, maybe you even think about the wind. Without realizing it, you are following a series of small questions. If it's cold, wear a coat. If it's warm, don't. This step-by-step thinking is not random. It follows a structure. In the world of data science, this structure is called a decision tree. A decision tree is one of the simplest and most powerful ideas in machine learning. It helps us make decisions using a sequence of clear, logical steps. To understand how it works, imagine a tree, but not the kind that grows upward with leaves and branches. In machine learning, trees grow downward. At the very top, we have the starting point. This is called the root node. The root node contains all the data we have. Nothing has been decided yet. It's just the full set of information, waiting to be split. From the root, the tree begins to ask questions. Each question creates a split in the data. These splits are called decision nodes. A decision node asks something specific. For example, is the temperature below 10 degrees? Or is humidity greater than 70%? Based on the answer, the data is divided into smaller groups. These divisions are connected by branches. Each branch represents an outcome of a question, usually something simple like yes or no. As we move down the tree, more questions are asked. Each time, the data becomes more specific and more organized. Eventually, we reach the end of a path. These endpoints are called leaf nodes. A leaf node does not ask any more questions. It gives us the final answer. For example, wear a coat, or do not wear a coat, or maybe it will rain. So a decision tree starts with all the data, asks a series of questions, and ends with a clear decision. Now the big question is, how does the tree decide which questions to ask? The goal of a decision tree is to create groups that are as clean as possible. To understand this, imagine a box filled with red and blue balls. If the box has a mix of both colors, it is messy. We don't have a clear answer. But if we split the balls into two boxes and each box contains mostly one color, that's much better. And if a box contains only one color, that is perfect. This idea is called purity. A pure group means all the data points in that group belong to the same category. The tree keeps asking questions to make the groups more and more pure. This process of repeatedly splitting the data is called recursive partitioning. Recursive simply means the process repeats again and again. Partitioning means dividing into parts. So the tree keeps dividing the data until it reaches the cleanest possible groups. But again, how does it choose the best question? The answer is it uses math. The tree measures how mixed or disordered a group is. This disorder tells us how good or bad a split is. There are two common ways to measure this. The first is called entropy. Entropy is a measure of randomness or chaos. If a group is perfectly mixed, like 50% red and 50% blue, the entropy is high. If a group contains only one type, the entropy is 0. So the goal is simple: reduce entropy as much as possible. When the tree tries a question, it checks how much the entropy decreases after the split. This decrease is called information gain. The higher the information gain, the better the question. So the tree always chooses the question that reduces chaos the most. The second method is called Gini impurity. Gini impurity measures how often a random item would be classified incorrectly. If a group is very mixed, there is a high chance of making a mistake.
If a group is pure, the chance of error is very low. So again, lower is better. Gini impurity is often preferred in practice because it is simpler and faster to compute. Many popular decision tree algorithms use Gini by default. Now, while decision trees are powerful, they also have a weakness. They can become too good at learning the training data. This might sound like a good thing, but it can actually be a problem. If the tree keeps splitting and splitting, it can start to memorize every tiny detail, even noise and random patterns that don't really matter. This problem is called overfitting. Overfitting happens when a model performs very well on training data, but poorly on new, unseen data. It's like a student who memorizes all the answers to a practice test. They might score perfectly on that test, but struggle when the questions change slightly. The model has learned the data, but not the underlying pattern. To prevent this, we use a technique called pruning. Pruning means cutting back the tree. We remove branches that do not provide useful information. This makes the tree smaller, simpler, and better at generalizing to new data. A simpler tree is often more reliable. Now, you might wonder, with all the advanced models available today, why do we still use decision trees? The answer is simple. They are easy to understand. Decision trees are transparent. You can follow every step from the root to the leaf and clearly see how a decision was made. And that is exactly how machines can learn to make decisions from data. Master this simple idea, and you take your first big step into the world of machine learning. The future of industry is intelligent. Let's build it together.